The topic of today's lesson is atomic structure. Our learning targets include being able to differentiate between protons, neutrons, and electrons in terms of their relative size, charge, and location in the atom. You'll also be able to determine the mass number and the atomic number for a particular atom. In this picture, we have a carbon atom. We know it's a carbon atom because of the subatomic particles that make it up. For example, there are 6 protons drawn out here, 6 neutrons, and if you count up the electrons, there are also 6 electrons. That's how we know it's a carbon atom. Atoms are the smallest unit of matter. They have a tiny, dense, positively charged nucleus. So if you take a look at the nucleus that's pictured here, you'll notice the only charges present are positive charges. So the nucleus for any atom is always positively charged. The nucleus not only contains protons, but it also contains neutrons. On the outside of the nucleus, we have electrons located on energy levels. We also call that region the electron cloud, and that surrounds the nucleus. Most of the volume of the atom consists of these fast-moving, negatively charged particles that travel through empty space surrounding the nucleus. So the volume of an atom is primarily made up of the empty space that the electrons seem to occupy. This chart gives us a nice summary of the proton, neutron, and electron and their characteristics. So starting with the proton, the symbol for a proton is a lowercase p with a positive sign. The location of a proton is the nucleus, and it has a positive charge, and that's why in the superscript position we have a plus sign. The relative mass of a proton happens to be 1 atomic mass unit. So AMU stands for atomic mass unit. This unit was designed to simplify explaining the size of a proton, because the actual mass of a proton is 1.67 times 10 to the negative 24 grams. And you can see that this value is quite small and probably inconvenient to write and commit to memory. So we have simplified the idea of the mass of these subatomic particles by creating a unit known as atomic mass units. The neutron symbol is a lowercase n with a 0 because it has no charge. It is considered to have a neutral charge, and it's also in the nucleus. The relative mass of a neutron is similar to that of a proton in that they both have 1 atomic mass unit or assigned to them as their relative mass. And the actual mass is also approximately 1.67 times 10 to the negative 24 grams. Electrons, the symbol is an E with a negative sign. The location for the electron happens to be in the energy cloud, or the electron cloud rather, or more specifically on energy levels. The electric charge of an electron is negative. The relative mass is actually much smaller than that of a proton and a neutron. Electrons are approximately 1,800 times smaller than a proton, and for that reason, we consider their mass to be negligible. So we say the mass of an electron is equivalent to 0 AMU. The actual mass in grams of an electron, though, is 9.11 times 10 to the negative 28 grams. So you can see there is a large difference between the masses of an electron and a proton. So how do atoms differ from each other? The number of protons in an atom identifies it as a particular element. The number of protons is also known as the atomic number. And you'll notice when we look at the periodic table next that the elements are arranged on the periodic table by increasing atomic number or increasing number of protons. So this is a periodic table that was published by the American Chemical Society. And you'll notice at the top with platinum, the key here shows that the atomic number in this version of the periodic table is listed at the top. If you look at the other elements on the periodic table and you go from left to right, so starting with potassium, 19, 20, 21, 22, 23, you'll notice that the periodic table is organized based on increasing atomic number. Let's take a closer look at the element potassium and examine the different numbers and words and letters that are in that box. So here is potassium up close. The number at the top there represents the atomic number, also known as the number of protons. The K is the element symbol. So every element on the periodic table has one capital letter associated with it. And sometimes if there's more than one letter, there's also other lowercase letters that are part of its symbol. Potassium is the element name, and the number at the bottom here, 39.098, is the element's average atomic mass, not to be confused with the mass number. So this is not the mass number. When we talk about isotopes, we will distinguish the difference between, or highlight the difference between the mass number and the average atomic mass. All atoms, by definition, are electrically neutral. Therefore, the atomic number not only equals the number of protons, this is always true, but for atoms, it also equals the number of electrons. So think about it. If we're looking at a neutral atom and we have 5 positively charged protons, to neutralize this positive charge, we will need 5 negatively charged electrons. The positive 5 and the negative 5 cancel one another out to get to this neutral charge of 0 for an atom. So remember, atoms are neutral. If it's not neutral, then it's not an atom. It's something else. It's an ion, and we'll talk about that at a future time. So what determines the mass of an atom? Well, the mass number is calculated using the 2 subatomic particles that we discussed that have a relative mass. So that would be the protons and the neutrons. The mass of the atom is concentrated in the nucleus because that's where the protons and neutrons are located. Remember, the electron mass is negligible. It is 1,800 times smaller, approximately, than a proton. So we can disregard it from any calculations involving the mass of an atom. Let's do a few practice problems here. So you'll notice that in yellow on the left side, we have hydrogen, boron, and iron, the element symbols. Notice there is no positive or negative charge associated with any of these symbols. So we are going to go ahead and understand that it's safe to assume that these are neutral atoms that we're talking about. So the first element, hydrogen, you'll notice the atomic number in this block located in the top left. So the atomic number of hydrogen is 1. And remember, atomic number always equals the number of protons. So we'll go ahead and put a 1 there as well. And because we're talking about atoms being neutral, you know that the positive particles, positive protons, the number of protons should equal the number of electrons. So we can go ahead and put a 1 here for the electrons. Now remember how to calculate mass number. The mass number equals the sum of the protons plus the neutrons. So we can understand from this simple mathematical expression that the number of neutrons should be 0 because 1 plus 0 equals 1 for your mass number. Boron, if you take a look at boron, boron's atomic number is given again at the top left there. So the atomic number is 5, and that would also mean that boron has 5 protons, and a boron atom would also have 5 electrons. Okay, this time we're given the number of neutrons. So remember to add the protons plus the neutrons to give you the total mass number. So that would be 11 for our mass number. Lastly, we have iron. Iron's atomic number is 26. That means we also have 26 protons, and the iron atom will also have 26 electrons. Now to calculate the number of neutrons, remember to take the mass number and subtract the protons from it to get the number of neutrons, which in this case, 56 minus 26 equals 30. So that's how you determine the subatomic particles present in a given atom.